Okay, today we're going to talk about one of my very favorite things ever, the Pythagorean Theorem. So first, let's talk about what even is the Pythagorean Theorem used for? Why do we care? Okay, what is it? So the Pythagorean Theorem is used to find a missing length in a right triangle. Okay, so if you have a missing length, any side, in a right triangle, we can use the Pythagorean theorem to find it. And so before we can talk about missing sides and all of that, we need to understand the parts of a right triangle. Every right triangle is made up of two legs and a hypotenuse. Okay, so two legs and a hypotenuse. And the hypotenuse is always the longest side, okay? And it's also going to be like the slanted or diagonal side. Okay, so in this right triangle over here, this side would be a leg, and this side would be a leg. And you'll notice that they make up the right angle. They also make the L shape, right? So if that helps you remember it, legs make the L. And then you can see how this right angle is kind of pointing over here to this long slanted side. This is our hypotenuse. So those are the parts of a right triangle. So now let's look quickly at this little example that I have down here. Try to make sure you can see it all. So if we were to look at this side and measure it by square units, right? It is 1, 2, 3, 4 units long. And so if I were to square 4, right? 4 squared, 4 by 4 would give me 16. So 4 squared gives me these 16 little boxes. And then down here on the bottom, you'll notice this is 3 across. And if I take 3 and I square it, 3 times 3 is 9. And I have 9 little boxes. So what's cool is that, I was looking for another color. Here we go. This side right here, if I were to count it, right? 1, 2, 3, 4, 5. Okay, but watch. So this is 5 squared. But look what happens. If I take these 9 and these 16, what did it equal? It equaled 5 squared. Whoa, I got hit a bump on my desk. Okay, so every single time, if you take the sides and you square them, and you add them together, every time it will equal the square of the hypotenuse. So written out as a formula, it is a squared plus b squared equals c squared, where a and b are the legs, and c is the hypotenuse. Okay, a squared plus b squared equals c squared, where a and b are the legs, and c is the hypotenuse. So if this was a, and I squared it, and this is b, and I squared it, a squared plus b squared, when I added them together, gave me c squared. So let's look at some examples. So letter A, okay, I have 10 and 8. So 10 squared plus 8 squared is going to give me my missing hypotenuse squared. So that's 100 plus 64 equals c squared. So 164 is c squared. This is not on my list, right? But I know that the square root of 169 is 13. And I know the square root of 144 is 12. So this, right, if I'm going to take the square root of both sides, because I don't really want to know what c squared is, I want to know what just c is. 164 is closest to 169. So we're going to estimate this side as 13. And it makes sense. This is the longest side. If these are 10 and 8, it makes sense that that would be 13. Okay, let's look here at letter B. So 12 squared plus 9 squared equals c squared, because I'm missing that hypotenuse. 12 squared is 144. 9 squared is 81. When I add these two together, I get 225 equals c squared. But again, I don't want to know what c squared is. I want to know what just c is. So I'm going to take the square root, and the square root of 225 is 15. So let's talk about if we're missing one of the legs. Okay, you can use the formula c squared minus a squared equals b squared to calculate the missing leg. Okay, it just kind of takes out a step and makes it an easier process. So like this one, right, I'm missing the leg. So I'm going to say the hypotenuse squared minus the leg that I know squared equals my missing leg squared. So 15 squared is 225 minus 12 squared is 144, and that equals b squared. 225 minus 144, 81, equals b squared. And then what's the square root of 81? 9. So 9 would equal b. Let's look at, or you could even try it on your own and then come back. But on letter D, we're missing a leg. So 13 squared minus 9 squared equals b squared. So 169 minus 81 is b squared. 169 minus 81 is 88. 88 is closest to 81, so 9 would be b. Okay, and then down here, it's what we know is that if the Pythagorean theorem works, or the Pythagorean theorem works for every single right triangle. So if we're given some side lengths, then what we can do is we can check to see if this fits the Pythagorean theorem. We'll know whether or not it's a right triangle. So for example, on this one, 8 squared plus 12 squared equals 15 squared. And if this is true, then it's a right triangle. So that's 64 plus 144 equals 225. When I add that together, 64 and 144, I get 208 equals 225. Is that true? This is not true, so this is not a right triangle. Okay, what if I gave you one that was like, it said it has sides of 10 and 14. So 10 squared is 100, plus 10 squared is 100, equals 14 squared is 196. It's close, but does 200 equal 196? No, so it's not a right triangle.